Audio Jungle. Audio Jungle. Audio Jungle. Audio Jungle.
Hello, hi, assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Engku Muhammad Shah HAKIMI bin Engku MOHAMMAD BUNIA, and today we have been assigned to present to you guys about the summary for programmable logic control BNE 22103, which have been taught by Miss Maya. So for the first of all, this subject, there is 6 major topics, which is the introduction to PLC, PLC selection, maintenance and troubleshooting, PLC programming, number 4, process sequence description, PLC input-output interface, and PLC application. So this is my team member, myself, Engku Muhammad Shah HAKIMI bin Engku Muhammad BUNIA. Our second member is Muhammad SYURAHBIL bin SHAMSUDIN, and our third member is Muhammad HAZIQ FARHAN bin ABDUL KARIM. This is the task distribution. We have distribute the task evenly for each of the member. For the task distribution have been assigned by me, and then objective have been will be presented by HAZIQ FARHAN, and it will followed by safety and health by SYURAHBIL, and then we will present to you guys about the learning outcome for from the week 1 to week 14, for the week 1 and week 4 until week 4 by SYURAHBIL, week 5 to week 10 by me, Engku Muhammad Shah HAKIMI, and then week 11 to week 14 by HAZIQ FARHAN. And then we will review the case study and have been chosen by our group, and the solve the problem by me, and then SYURAHBIL will explain to you guys about the troubleshoot error for the case study, and then we will present to you guys about the most difficult topic in this subject with the solution. And then for the conclusion, HAZIQ FARHAN will conclude all of the assignment.
So for the objective of this group assignment is a simple presentation against the whole topic that had been covered by Puan Sumaya from week 1 until week 14. So basically we will just do some summarize, which is by each member for from week 1 until week 14, and the second one is to familiarize the CX programmer using the CPU1E processor for the conveyor belt, which is for we choose for from SYURAHBIL's group design project before this. So later we my group members will teach you the CX programmer. And the third topic is to discuss about the most difficult topic by each group members and giving some suggestion for a better learning outcome. So this third objective is each group members need to find the most difficult topic and need to give some suggestion for a better learning outcome.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So for my part, I will explain to you guys about the safety and health during our programming logic control, or using CX programming. So I separate this part for several parts, which consists of project design precaution, software and installation precaution, wiring and installation precaution, and also disposal precaution. So for project design precaution, there are several things that we need to understand and we need to require in order to ensure our safety and health during conducting this software or this PLC. So firstly, we need to understand the process sequence. Either we use the simple method or so on. And then we need to do a design of safety process, such as we do an emergency exit, emergency stop, interlock, or we put our project in a standby mode. And then for the software and installation precaution, So we need to confirm our safety sufficiently before transferring our I/O memory status from CX programmer to the CPU unit, and the device connected to the output units may have a malfunction. So caution is required in order to protect our functions. So next is we cannot turn off the supply of the PLC or disconnect the connecting cable while the CX programmer online transferring from the PLC to the CPU. So for the wiring and installation precaution, in order to do that, we need to make sure all terminal, this is basic, we always do, which is make sure all terminal are connected properly to the processor before we turn on the supply or load. And then check the wiring, always check the wiring after we complete all the wiring. Make sure to check the wiring after being installed before we insert the supply. And then make sure the conveyor, if we use conveyor, make sure the conveyor in a good condition. So for my case study during my project design, I use a conveyor. So if I do that project, I need to make sure that my conveyor belt is in a good condition so that we can protect our safety and also help during conduction of the project. And also if we use any battery or things that may burn, so we need to place it far from the heat to avoid electrical shock. So for the disposal precaution, so for all electronic device, make sure we need to dismantle the device and treat as industrial waste. We cannot throw it in a dustbin. No. We need to make sure it throw as industrial waste before we throw the device away. So that's all for safety and health. So now I will explain about the weekly activities that done during this semester. So I will start with week number 1. So for week number 1, we have done the Industrial Top 2021 series with title PLC, Pneumatic and Hydraulic Application Industry. This is the first time we hear or learn about PLC. So this talk held on 29 March 2021 via Zoom. So I hear the talk by the recorded version as my internet quite not good to attend via Zoom. So the we learn from this webinar is about the application of PLC, and of course first is this definition of pneumatic, hydraulic, and also PLC. So hydraulic is a branch of science and technology which is concerned with conveyance of liquid through pipe, and pneumatic is a branch of engineering that uses gases and pressure. So it used in industry that powered by compressed air and compressed inert gas. So there are advantages of pneumatic and also hydraulic, which is a compressed of air, easily transport, and explosion proof, and which where hydraulic is more power, easily being controlled, and the liquid don't absorb any type of energy. So the main focus for this during the webinar, I focus on the PLC part, which is PLC. The definition, as we know, the PLC is programmable logic control. The definition is used for industrial automation that designed to operate in harsh usage environment and conditions such as strong vibration, extreme temperature, and also wet daily condition. So what is the advantages of PLC? Of course, it's human machine interface and also CPU module and I/O module. So that's all that we learn during that webinar. I have transferred it to the mind map activity, and mind map being sent in Octal. So that's all from me. Next is for week number 2. So week number 2 activities is Miss Maya share with us about the PLC course activities on previous semester. So Miss Maya shared via author. So I downloaded the slide. So I managed to capture some important things from the slide that I need to explain, which is Miss Maya share about the activities that done during physical class, which is PLC application that learned during physical class at the lab. And next is number 5, which is online learning for our current state during this pandemic. So we do the online learning. So Ms. Maya share the video presentation and also group project presentation from our seniors by Excel. So Ms. Maya have highlight some group that their design project quite good that we can make as an example. So another one is about the PLC industrial application design. Ms. Maya also shares some project which is fully automated washing machine by our seniors. So that's all for week number 2, where just some sharing on previous semester PLC class activities. Okay, now for week number 3. Okay, for week number 3, there are 2 parts. I split into 2 parts, which is firstly our subject introduction, and also we enter to chapter number 1, which is introduction to PLC system. Okay, as this one is the first online class with Miss Maya. So Miss Maya explained to us about the subject PLC, which firstly is the course learning outcome CLO, which one of the CLO is analyze the PLC programming using different process description to control an automation system for various application. This one is for the knowledge and respond in group effectively by solving the assignment and case study or project given. This one is for individual and teamwork. And of course, program testing and troubleshoot the error in PLC programming using CX programmer software to solve the engineering problem. This one is for modern tool usage. So other than that, Ms. Maya also explained about assessment and also the course plan for this full semester for subject PLC. Next is the introduction of PLC. For introduction of PLC, there are 2 parts, which is part 1 and part 2. Part 1, Ms. Maya explained about the definition, application, and also advantage. And also for part 2, Ms. Maya explained about the PLC system and operation. For the definition, as we know, PLC is a programmable logic control. So used to for basically for industrial automation, it's designed to operate in harsh usage such as in heavy, strong vibration, extreme temperature, and wet daily condition. So for the application of PLC, there are many applications such as in oil and gas, which is for pipeline transportation improvement, turbine operation, and also for cement manufacturing, also smart factory, where in smart factory they send robust data, including sensor performance that can be integrated with cloud. So other than that, the advantage of PLC. What is the advantage of PLC? So PLC is normally easier than relay system. So next is PLC more reliable than relay system. And if we use PLC, it will be easy to troubleshoot as it consists of error, and there are many reference that we can refer, such as the module. And also the PLC is flexible and robust control solution. So next is for part number 2, which is PLC system and operation. There are 4 stages. How does the PLC function? There are 4 stages of PLC, which is self-test, input test, logic scan, and also output scan. So this stage repeated turns to 100 times per second. And for PLC operation, firstly they are reading input. After that, they will execute logic and also writing output. In PLC, there are also ladder diagram. They are consists of rung logic that read from left to right. Left is input, right is for the output. And PLC, they have a scan from left to right, horizontal for horizontal scanning, run, run 0, and also vertical scanning from top to bottom, and also the IO memory reference. So this all the activity that we done at week number 3 for this all. Thank you. Okay, lastly for week number 4 activity. So during this week, the activity that we done is a pre-lab activity, which is the familiarization with PLC onboard, CPU1E, and CPU units. So there are some questions that we need to answer during this activity. There are pre-lab activity that Ms. Maya give author. We need to firstly we need to identify the different features for 2 different PLC model. So as you can see in this picture, this one is a 2 different PLC model. So first one is CPU1E T20 SDRA, and also CPU1E and 20 DRA. So the class for each model is first is the basic model, E is a basic model, and N is an application model. So as you can see, as I mentioned earlier, the model number, we can identify by the model number either the class of the model, either basic model it require the E letter. If the application model will use the N letter. So other than that, they are consist of 20 input and upon, where 12 input and also 8 output. So the different features about the I just did one different features, which is for basic model, it consists of your USB port only, while application model it built in with your USB, battery, and also RS2232C ports. But for application model, the battery set to 1 watt battery for backup data if any power interruption occur. So that's the different features between these 2 models. I just state one. This one all we collect from the data sheet of the model. So next is the system configuration for basic and application model. So we need to identify. And lastly, we need to check the memory reference for CPU1E. So this one we just use the CX programmer. So we go to the help menu and we just find the IO memory reference for CPU1E, then we will check the memory reference by using the pre-lab activity. So this activity basically explain to us about the PLC on-run CPU1E model, and also give some familiarization to using the CX programmer software and also PLC on-run CPU1E. So I think that's all for this week.
In week 5, there are 3 major parts for the learning outcome. First of all, we have learned about the basic of the diagram. Second one is we have learned about the basic logic function, and the third one is we have learned about the ladder logic function. Before we are moving forward to our discussion, I would like to recall or do some revision with you guys about the why and what is the ladder diagram. Commonly, ladder diagram is a document in which used in the industrial to control logic system. The system is called ladder because they resemble a ladder. As you can see at the bottom left, I have put an example of ladder diagram, and then with 2 vertical bus bar This part is the bus bar. This part is the bus bar, and there are a few horizontal line which is we call round to represent the control circuit. In this course, we are using the Omron CP1E E20, and then the address for the input output is 20. And then we also learn about the basic of normally open and normally close contact and their connection. And then third one, we have learned how to convert ladder diagram to mnemonic code. This is an example of conversion from the ladder diagram to the mnemonic code. And then we have learned about the basic logic gates function. This is just basic logic gates function as you guys have learned in physics and digital course. And then in week 5, we have also learned about how to write mnemonic codes. We are using we have done a table which consists of round, step, instruction, operand, and command. I think that's all what we have learned in week 5. Thank you.
In week 6, we have a few case study. For example, for the float sensor, the second one is latch push button, which applying the normal latching concept, which is the same as set. It's the same as keep instruction. And then the third one is traffic light. This is just a basic traffic light, which consists of 2 green and 2 red lamp. When both of the green lamp is turned on, an alarm will set. And then there is a car. The car mechanism is basically based on the seatbelt at the passenger and drivers, and the pressure sensor, which indicates that the seat is occupied or not. And then the fifth one is the machine. For a safety reason, the machine need to be 2 of the button need to be pushed for the machine to be operated. Thus, we need to identify the input output first, and then the boolean for the boolean expression. If button 1 and button 1 and button 2 is have high value, thus the machine will operate. We need to push both of the button to make sure the machine is operating. And then in week 5 also, we are learning about the steps before writing a ladder diagram. Before we are writing a ladder diagram in the CX programmer, we need to, this is just for a basic program. We need to write a logical expression which made up of input, output, and identification. I have showed this earlier. If we are using the CP1E E20, and then we need to consider the input output first before we are writing the ladder diagram. And then to increase our understanding for the program, we need to do the truth table first. And then we will, based on the truth table, we'll write the Boolean expression. And then we'll write the ladder diagram and do some analyzation in Work Online simulator. And then if there is error, we need to do troubleshooting and debugging. And then process sequence description, PSD, we will explain about this later on. Is necessary in more complex system. So if the system is much more complex, we need to do the process sequence description to make sure that we understand the program or system fully. Moving forward to the week 7. In week 7, based on the diagram shown, we have learned about the cycle of program development. Let me explain it a little bit. First of all, before we are writing the ladder diagram in CX Programmer, we need to do the writing and editing for the source code, and then we need to compile the program, and if there is an error, we need to go back to the writing and fix the error, which is known as syntax error. And then if the program is working just fine by using the Work Online Simulator, and then the machine code will be uploaded from the PC to the PLC, which is the processor that we have chosen in the CP1EE20 or so on. And then we will do online editing or debugging. And then in week 7, first of all, we have learned steps in writing the ladder diagram in CX Programmer. And then the second one, we have learned determining the type of error in the program. There are two types of error, which is syntax error and logical error. And then we have learned how to use the Work Online Simulator as in the CX Programmer software. And then we have learned how to upload these program from the PC to the PLC, which is our selected devices or processor. And then we have learned how to use the online edit windows. During the week 9 and 10, Ms. Sumaya have assigned us to do a project design, and the assignment is a 3 team member. This is the learning outcome from the project design. First of all, the student will learn how to analyze the PLC programming using Omron CP1E series to control an automation system for various applications. The second one, program testing and troubleshooting the error in PLC programming by using CX Programmer software to solve the engineering problems. And then the third one is observe and analyze the operation of the PLC programming by using Work Online Simulator and make necessary modification based on the case study. And then response in a group effectively by solving the assignment and case study project given. First of all, the students need to submit a technical report with the oral video presentation. We need to do some introduction, safety precaution, the programming. We will write the programming from the first step, from the PSD, process sequence description, and this is really up to the student. Either they want to use the motion diagram or simple narrative for the PSD, and then the student need to program a ladder diagram based on the case study.
11, we had an industry talk on 1st June 2021, which is the topic is about PSC and SCADA application from industry perspective and experience sharing. And we had 2 panel, which is Muhammad Syukur Abdul Rahman and Natasha Aira binti Abdul Rauf, which is both from alumni BND. And for the panel 1, Muhammad Syukur Abdul Rahman, he talked about his job experience, which is he worked for a small company and need to do a better since his CEO can see his ability, and explaining about the chart of manufacturing, talk about experience, responsibility and duties as a worker, and many more about his job experience. And for the panel 2, Data Syairah binti Abdul Rauf, she talked about types of PLC that we had on the industry, SCADA system, scenario LPG port. So both panel talk about their own experience, and each of it is quite useful for us to know what they had been do right now. So it's quite interesting in the industrial talk. And for the most thing that I like in this industrial talk, which is the last topic, which is we had a simple Q&A session with student, which is student can ask any question about the patient kadar patient from the perspective and space sharing for their knowledge, and both of the panel answer it quite useful for us, and I enjoy it because the panel is so friendly and it is so useful for our future. And this is my simple mind map for the industrial talk. Okay, for the next topic is for the week 12. We had Puan Sumaya give us self-learning to familiarize with CP1E trainer kit, which is we had 5 topics, which is for the first topic is PLC conveyor motor. For the second topic is semi-automatic liquid mixing application. The third topic is sequential motor control. The fourth topic is latching circuit, and for the fifth topic is interlocking motor control. So basically, we need to familiarize with the CP1E training kit, and we had studied by ourselves for this week. And for the next topic is for the week 13, which is Puan Sumaya just do some Google Meet to discuss about group project that we need to do right now. So basically, it is about a video about summary about the whole topic that had been covered by Puan Sumaya from week 1 until week 14, the assessment and the briefing about test 2 that we had on next week, which is week 14. So basically, the test 2 is about cognitive and psychomotor test, and Puan Sumaya had briefed about it nicely, and we had to study about the topic that we had on the test 2. So, and the last thing is she talked about activity that we had from week 1 until week 15, which is easier for us to make this video because we know what we need to do for our topic in every week. So each member had their own topic. So by this briefing, it's easier to us to choose and what to choose and what we need to present on our group assignment project. And the last thing, the last week is for the week 14, which is extra note on process sequence description and on timer and counter, which is we had 4 topic, which is first topic is single acting cylinder. For the second topic is SAC, which is single acting cylinder also but with counter. Third topic is automatic bottle filling system. For the fourth topic is extra note for interlocking to motor control. And the last thing, we had test 2. Like I thought it for the week 13 that we will had a test 2 on the week 14, which is on 29th of June 2021.
And so me and my group have done some discussion to fulfill the fifth requirement in the rubrics for the PLC subject for by Ms. Sumaya, and we have totally agreed to pick SYURAHBIL's project design from Group 10 as our case study. Like always, before we write a diagram, we need to follow a few steps to improve our understanding about the program. So like we all can see right here, this is the program. This program consists of a conveyor belt that running with a support of motor. When the product in the packaging system run through this process, there is a sensor that count the product. So we need a sensor and then count the product. Thus we need the counter in this program. So in this project, the values is set to the 5 product and it will energize the solenoid. So we need a solenoid, and then the counter will be set as 5. So first of all, we need to clarify the input output address. So for the input, we have push button on with the address of 0.00, and then push button off with the address of 0.01, and a sensor with the address of 0.02. For the output, we need to have a output for the conveyor motor with the output of 100.00, and then solenoid 100.01, and then we need internal relay. Internal relay we can pick from the range of 1.00 to 99. So we'll pick 1.00, and then the counter, which will be named as the address is C000, and a timer with T000. Okay, so after we have clarified the address for input output CP1E E20, so we need to do the process sequence description. In this part, it is really up to you. Either you want to use the motion diagram, the graph set method, but in this case study, we'll use simple narrative. This is the part column for input, and this is the column for the output. So number 1, push button PB with the address 0.00 is pressed. The internal relay with the address of 1.00 will have the value of we have high value, and the conveyor motor will with the address of 100 will energize. And then the sensor with the address 0.02 detect product, and then a counter C000 countdown for until 5 products. After the counter finish the count, solenoid will extract for 5 seconds, and then after the timer finish or time's up, the solenoid will retract and reset the counter. So, and then number 5, when the push button off with the address of 0.01 is pressed, it will stop the conveyor motor 100.00 and all of the operation. So after we have fully understand the program requirement, we can open the CX programmer, and then click file, new. We put a name for our program. I put case study 1, and then device type, we are using the CP1E E20, and then we click OK, and these windows will pop up, and we can start to write the program. So first of all, we need to have a push button on for the program. We put the address 0.01, and the program is the NO contact is push button on, and then we need a push button off, so we need a NC contact with address 0.01. The name is PB off. Okay, so we will have internal relay right here. So we click output. So internal relay we will use channel 1.00, and we open the name as IR. Internal relay, internal relay, since we will use just one internal relay. And then for the, we'll have normal latching right here. So we'll put normally open contact with addresses of same as the internal relay 1.00, and then we'll connect this parallel with the push button on. So we have finished the round for the round 0, and then the program want us to move a conveyor belt by using a motor. So we need to power the motor. So we'll put an O contact right here. for the internal relay 1.00, and then we'll have output right here. Since we have clarified that the address for the motor is 100, so we'll put 100.00 right here. So we'll name it as motor. But then, so sorry, motor. Okay, so when we push the button, and the normal latching will keep the system as always high, the value as always high, and we'll move the conveyor belt. Now conveyor belt has moved. Now we proceed with round 2. And then we need a sensor when it count to 5, and then the solenoid will push the item. Okay, so we need internal relay right here, 0, and then we need contact for sensor. For sensor, we'll put as 0.02. We'll name it sensor, and then we'll put a counter. Wait a minute. And then we'll put a counter, and then CNT counter, counter 0, and we'll count it. The value is 5. Okay. So right here is the reset, and then this input is the upper reset input. So we need a timer. We need to put a timer, and then put timer. I'm so sorry. 0. Right here, and then this is the timer. I'll connect with this input. Okay, so now we have a counter which connected with this sensor. The counter will energize when the counter is 5, 4, 4, 3, 2, 1 in count in descending order, and then it will energize and push and power the solenoid. So we need a contact for solenoid. For the counter is C000, and then we name it as counter, and then we'll connect it with a solenoid. Solenoid will use channel 100.01. So output 100.01. So this is the solenoid. So we need to have a timer right here. So when the timer is runs out, so it will reset the counter, and the system will continue over and over again. So we need contact for the solenoid. Solenoid is 100.01, and then we'll connect it with a timer. The timer, will put it as timer 0, and the value is since we want the timer for 5 seconds, so we'll put hashtag 50. Okay, so we have finished this ladder diagram, and then we need to compile it by using the work online simulator. Push it right. We click right here. Bismillahirrahmanirrahim. So there is no error, and we can use this program. We can test this program after this. Okay, so we have finished writing our ladder diagram, and so we need to test this program by using the work online simulator. When you click here, it shows that there is no error. So when we push the push button, we put value of 1, and then we put value of 0, or we release the push button. The program will run out, and then the sensor will detect the item that moving by using the conveyor belt. Right here we can see that the motor will running, and so thus the conveyor belt will be turned on. So we can use Control J, Control K, Control J for value 1, Control K for value 0. Okay, we put Control J, Control K. We can see that the counter is decreasing. So if the sensor detect 5 items right here, and then we can see that the timer is running and the solenoid is turned on. And then when the timer is run out of the number, and then the program or the motor will run. So this program will keep repeating itself over and over again. We'll try it once again. 2, 1, 0. Okay, so solenoid push, and the timers runs out. So the counter will back to its value.
Okay, now for the next part which is trouble error. So during our learning process, doing the project in the CS program, there are such somehow when we do the project where we encounter some problem with some error. So I separate the error into 2 parts, which is a syntax error and also the logical error. So during our learning process for this subject, I managed to learn from some error, which is firstly the run not connected to the output. So when we draw the ladder diagram with the CX programmer, there are one time where I do the project, and then at the end I not connected the run into the output. So the output is hanging. So when we compile the project, there will be an error because our rung cannot detect the output. There are not a complete ladder diagram. So that is the first part for the syntax error. And the second part is error when I do the IO memory reference. So when I do the memory reference, such as for the timer, sometimes I'm not able to do the IO memory because just do the ladder diagram. So when we enter the IO memory reference, when we compile, it cannot detect. There will be a red note in our timer that said that the process is cannot identify. So lastly, it's not connected to the bus bar. This one is same with the first one, which is the ladder diagram is hanging. So for the first week, first and second week, yeah, this problem always happen repeatedly because our first time using the CX programmer. And then for the logical error, also for logical error, this one I managed to encounter during my case study project. So the logical error that I encounter is when I compile and then the ladder diagram is not having a syntax error. So when we compile, we need to simulate. Then after we simulate, after we need to run the project. So my project consists of a sensor, proximity sensor, and also a counter. So the sense will sense the object and then send input to the counter. But when I simulate my project, the counter cannot detect the sense of the product. So during the simulation part. So this one is not a error of the project. So I consider it as a error for my project only because of the we need to do it manually. If we use any sensor, so we need to simulate the project. Then we need to active high and active low at the sensor in order for us to send input pulse to the counter. Because when we do a simulation, the sensor cannot show its own its function. So that's why we need to do it manually by doing a active low at the sensor, so that the counter will detect the pulse and start its count. So that's all the trouble area. Other than that, more for the syntax error when we do the ladder diagram, such as the ladder diagram for the or node. So from this area, we managed to learn for our PLC and how to use the CX programmer.
Okay, in my opinion, for the most difficult topic and my own suggestion for uh, to improve the understanding about the topic, I think it is during the week 7 in PLC instruction. During this week, I know Miss Sumaya have tried her best to understand, to explain the students about how to use the CP1E processor, but since we are under pandemic and we are undergoing the online learning, I think the best way to demonstrate the how to use the processor CP1E is by using the live stream type. So Miss Maya maybe can explain the how to use the CP1E not in a video but in a live stream, since the student can ask the question on the spot.
So for the most difficult topic that I think is of course week 7 PLC instruction, where in this topic we need to learn about the chip instruction, the log, latching, and so on. So for me, the most difficult part is of course interlock, and how I overcome a problem is firstly I learn from YouTube. I search for the example of interlock and I redo the case study in my CX programmer, and I try to time the program and learn from it. And also I ask from my friends, um, they explain to me about things that I don't understand. And lastly is I learn from the help menu from CX programmer and also Google. If I have any error or any problem that I encounter, I try to Google it and I try to understand in order to encounter the problem. So I think that's the most difficult topic. PLC is quite fun, but somehow we need to have a courage to learn in order to capture all the topics that we learn in this semester. So that's all.
Talk about most difficult topic and suggestion. So for my most difficult topic and suggestion, I choose for week 7, which is expansion of PSC program. Why I choose this week? Because it is for the basic of the PSC program. So why I choose this as a difficult topic? Because if we want to know the whole topic, we need to know from the basic. So basically, it's quite hard for me to understand what is PhD program is all about, and it's quite hard for me to understand how to use as example how to use counter, how to and when to use the counter. So my suggestion is Puan Sumaya can do some video explain about a little bit detail about every single part that we need to know about this PhD program in CP1E processor. So if as example which is about the counter, if Puan Sumaya makes one video about the counter that shows about, okay, for this program we need to choose counter for what, for the lapping and something about that. So for me it is quite useful because it gives me more easier to understand for each topic that we need to do and each topic that we need to understand. So thank you. But the last thing, which is the conclusion. So for the conclusion of this group assignment project, which is, for the first one is that we had summarized the whole topic from 1 until week 14 that already been presented by each group members clearly and successfully. And for the second thing is simulation of the CX programmer using the CPU1E processor had been shown on the previous slide and presentation. And for the last thing is most difficult topic as suggested by each group members, and the suggestion for a better learning outcome had been explained clearly. So every objective already had been successfully did by every group members, and I'm thankful a lot for each group members that helped me in this group assignment project, and thank you for all the cooperation. And